And welcome back, students, as we get to discussing binary files. All right, so to kick this off, we're going to discuss writing simple data to a binary file. All right, so getting started. Binary files, remember, they're different than that of, like, for example, text files. Binary files' purpose is to store data in the same format that is used in the computer's memory to store the value of variables. So, for example, the value of type int is stored as the same sequence of bytes, or the same sequence of zeros and ones, whether it is stored as an int variable in memory or in a binary file. So pretty much no conversion then needs to take place of any kind when you store or retrieve a value within a binary file. And this is why binary files can be handled much more efficiently than that of text files, because the computer doesn't have to do the conversion. All right, so we start talking about binary files. The first thing you got to understand is that binary files kind of vary from what makes them. So since we're dealing with Java, let's look at Java binary files, and they're not exactly always like other binary files, in that from other programming languages that pretty much Java files are portable. Remember, one of the big strengths and appealing things of Java is that it's cross-platform. So you can take a file on a Mac and run it on a PC and vice versa. Now, a binary file created by a Java program can be moved also from one computer to another and still be read by a Java program. Caveat, though, is only by a Java program, because because it's a little more unique, it has to be run by Java. Now, they cannot normally be read by a text editor. So if you try and open up a binary file with text editor, it's not going to really work, right? Or with a program written in any programming language other than Java. Like if you have, let's say, try to open up a Java file with like a C# editor, it's not going to work. The binary file is written for Java. Now, the preferred stream classes for processing binary files are that of object input stream and object output stream. Each has methods to read or write data 1 byte at a time. Now, these streams will convert numbers and characters to bytes that can then be stored in a binary file. They allow your program to be written as if the data placed in the file or read from the file is not just bytes, but also strings or items of any Java primitive data types, such as int, char, and double, or even objects of classes you define. You do not need to access your files using an editor. Then the easiest and most efficient way to read data from and write data to files is to use binary files in the way which we describe here. So we're going to conclude this lesson, with a discussion of how you can use object output stream and input stream in order to write and later read objects of any class you define. This is going to let us store objects of the classes you define in binary files and later read them back, all with the same convenience and efficiency that you get with storing strings of primitive data types in that of binary files. All right, so let's actually look at writing some simple data. Now, the class object output stream is the preferred stream class for writing to a binary file. It's not like it's kind of like we have buffered reader for things, kind of very similar there, but it's obviously not the same as, like, for example, our scanner class. An object of the class object output stream has methods, therefore, to write strings and values of any of the primitive types, such as int, bool, char, etc., to a binary file. Now, binary output demo shows a sample program that writes values of type int to that of a binary file. So let's just go ahead and quickly pop over here to Eclipse. And you can see here I have a few import statements. I have object output stream, file output stream, and IO exception. And what this does is it has a try block here that says to use object output stream. New object output stream use numbers.dat. So it's going to write to this numbers.dat file. Int I for I equals 0, I is less 5, I plus plus, output stream.write int I. So it's going to simply just write out the value of I. So do 0, 1, 2, 3, 4. Right? Then it's going to say numbers written to the file. I'm going to close the output stream. And then, of course, we have this catch block here that's going to attempt to catch it if there's a problem writing. So one thing you'll notice is that almost all the code in our binary output demo is within a try block. Any part of the code that does binary file I/O in the ways we are describing can technically throw an I/O exception, so we need to make sure that we're handling that. Now, the output stream for writing to a binary file numbers.dat is created and named with the following: object output stream equals new object output stream, new file output stream numbers.dat. So that one line of code right there is what is responsible for ultimately writing that binary file. Now, methods of the class object output stream are that follows. So you can do public void write float, float x throws IO exception. What this does is it writes the float value x to the output stream rather than an int, for example. We have write char int n, which throws an IO exception. This will write a character value n to the output stream. We'll note that it expects the argument though to be that of an int value. However, if you simply use the char value, then Java will automatically typecast it to an int value. So the following are equivalent: output stream dot write char int a and output stream dot write char a. Right? So both of those are equivalent. Right? Because you remember, reason why it's writing as acting as int, you might wonder why is an int. If you remember, characters are a representation typically of the ASCII character set, so it's corresponding to that value within that set. Public void write UTF string a string throws IO exception. This writes the string value a string to the output stream. UTF refers to a particular method of encoding the string. So to read the string back in value, you should use the method read UTF of the class object input stream. So UTF is another encoding of how you can encode your characters. You'll see it occasionally used from time to time. All right, we also have write object, which writes an argument to the output stream. The object argument should be an exception of the serializable class, which is a concept we'll discuss in the later lessons. We'll talk about what it means to be serialized. Now, of course, now this class right here can throw various IO exceptions because obviously you're not just doing an int or a char or anything like that. Public void close throws IO exception. Obviously, close is very important to close your stream's connection to the file. This method calls flush before closing the file. Public void thrush throws IO exception will flush the output stream. This forces an actual physical write of the data that has been buffered and not yet physically written to the file. Normally, though, you do not need to invoke flush because if you close, it takes care of things. All right, now let's actually look at how to open a file. As with text files, it's simply just called opening the file. All right, nothing really has changed there. The only difference is that it's a binary file instead of a text file. If the number .dat file does not exist, this statement simply is going to create an empty file called numbers.dat. Now, if the file numbers.dat already exists, the statement will erase the contents of the file, so the files will start out empty. Now, the situation is basically the same as what you learned for text files, except that we are using a different class. So you'll see a lot of similarities as we start moving into this. As is typical in Java I/O, the constructor for the class object output stream takes another I/O class object as an argument. In this case, an anonymous argument of the class file output stream. All right, now let's see exactly how you do that binary file. So you're going to create a stream of the class object output stream and connect it to a binary file using the following syntax. Object output stream output stream name equals new object output stream new file output stream file name. That's a lot of output stream to say. So the constructor for file output stream may throw a file not found exception, which of course, if you remember, is a type of I/O exception. Now, if the file output stream constructor succeeds, then the constructor for object output stream may throw a different type of I/O exception. So a single catch block for I/O exception technically will cover all classes, and that's why you see it just throws I/O exception. So in here we have an example. So object output stream, my output stream equals new object output stream new file output stream my data.dat. Again, there's a lot of object outputs. Sorry to get myself tongue twisted over all of them. All right, now after opening the file, you can use methods of the object output stream to write to the file. All right, so let's look at one of these methods for writing to the file. And the first one, of course, is write_int. The class object output stream does not have a method named println, as we had with text files and screen output. However, as shown in our binary output demo, an object of the class object output stream does have a method named write_int that can write a single int value to a file, and also has other output methods as described. Within binary output demo, there are no lines or other separators between the numbers. So if you actually could view the data file, you're not going to just see, like, for example, it's going to go 0, 1, 2, 3, 4, each on their own line. Rather, it's going to be 0, 1, 2, 3, 4, all on the same line. However, it won't be written as 0, 1, 2, 4. It'd be written in binary. So like 0 would just be 0, obviously 1 would be 1, but then 2, for example, is like 1, 0. 3 is 1, 1, etc. Now, the numbers are written in the file immediately one after the other, and they are encoded as a sequence of bytes in the same way that the numbers would be encoded within the computer memory. These coded values cannot be read using a text editor. And realistically, they can only be read by another Java program. Even if you could, all right, one thing that might throw you off is it's not necessarily going to be like 0, 1, 1, 0, 1, 1, 1, 1, 1. It's not going to be like that. Instead, it's going to typically be written out more in a series of, remember how bits and bytes are, groups of 4 or 8, is how you'll typically see things. So you're going to see these numbers written out. So like, for example, 0 may not be just 0. It might be 0, 0, 0, 0, 0, 0, 0, 0. So pretty much 8 zeros is what you're going to end up seeing if you could actually view that, because it might be using a sequence of 8 numbers to represent that int. Now, it might be more than that, but realistically, you're not going to have to worry about that because, again, that's all going to be stored in the data file, and we can't view that anyways. Now, we can use a stream from the class object output stream to write values of any primitive type and also to write data of the type string. Now, each primitive type has a corresponding write method in the class object output stream. Of course, here's the first one, write int. All right. So we've already mentioned the methods for outputting data of the int values. The methods for the other primitive types are really analogous to write int, so they're going to function exactly the same way. So, for example, the following would write a double, a boolean, and a char value to that of the binary file connected to object output stream. So we have output stream dot write double 9.99, object to output stream write boolean false, and output stream dot write char int a. So all those technically function the same. All right, now let's just take a moment and look at write char, because write char is slightly different than those other primitive types. Right. The method write char has only one possibly surprising property. Right. If you remember, it has its argument to be type int. So when we're looking at write char, if you start with a value of the type char, the char method can be typecast to an int before it's given to the method write char. For example, to output the contents of a char variable named symbol, you can use output stream.write char int symbol. In actual fact, you do not need to write in the typecast to an int because Java automatically performs a typecast from a character value to an int for you. So the following is equivalent, as we've mentioned previously, to our invocation write char. Output stream.write char symbol. Right. So personally, I would probably do it the second way here, simply because it's one less thing I have to type and one less set of parentheses I have to worry about forgetting about. All right, let's look at write UTF for strings. So to output a value of type string, we can use the method write UTF. So for example, if output stream is a stream of type object output stream, the following will write string hello friend to the file connected to that output stream. Output stream.write UTF hello friend. Now you may write output of different types to the same file. So you can write a combination of, for example, int, double, and string values. So your file doesn't have to be all strings. It doesn't have to be all ints. You can mix and match. However, one caveat to note is that mixing types of these files within your data file does require special care to make it possible to read them back out of the file. So to read them back, you need to know the order in which the various types appear in the file. As you see, a program that reads from the file, we use a different method to read data of each different type. Now you'll note that as illustrated in our binary output demo, and as you'll see shortly, you close a binary output or input stream the same way you close a stream connect to a text file using .close. Alright, so recall that Java uses the Unicode character set, which is a set of characters that contains many characters in languages whose character sets are different in English. Now, we're using editors and operating systems that typically use the ASCII character set, which is the character set normally used for English and for Java programs. Now, the ASCII character set is actually a subset of the Unicode character set. So the Unicode character set has a lot of characters you probably don't need. Now, there's a standard way of encoding all the Unicode characters, but for English-speaking countries, it's typically not a very efficient coding scheme because we're not going to need all those extra characters. if we're just sticking to just straight English. Now, if we start pulling in multi-level or multi-language support kind of things, or we're going to be broadcasting this across multiple different platforms, etc., yeah, we might want to expand it to include the Unicode character set. Now, the UTF coding scheme is an alternative scheme that still codes all Unicode characters, but that favors the ASCII character set. What the UTF coding method does is give short, efficient codes for all the ASCII characters. The price, though, is that it gives long, inefficient codes to other Unicode characters. However, because you're probably not going to use the other Unicode characters, this can be a favorable trade-off. Right? So unless you're going to be starting delving into other things, besides just that of the English character set, UTF is probably going to work fine. Now, the method write UTF is going to use UTF coding method to write strings to a binary file. The method write int, if you remember, writes integers into a file the same number of bytes that is the number of zeros and ones to store in an integer. Similarly, the method write long uses the same number of bytes to store each value type long. But the methods of write int and write long use a different number of bytes from each other. Now, the situation is the same for all the write methods that use write primitive types to that of binary files. However, cycling back around to our friend UTF here, you'll notice that its method uses different numbering of bytes to store different strings in a file. Longer strings require more bytes than that of shorter strings. And this is because a string, if you think about it, can vary vastly in length and complexity compared to that of an int or a long. Now, this technically can present a bit of a problem to Java because there's no separators between data items in a binary file. It's not like it puts on the next line or anything. It's all one big long string of numbers. Now, the way that Java managed to make this work is by writing some extra information at the start of each string. This extra information tells how many bytes are used to write the string, so read UTF knows how many bytes to read and convert. The method read to UTF will be discussed a little later in the chapter, but as you may have already guessed, it reads a string value that was written using the UTF coding method. Now, the situation with write UTF is a little more complicated than what we discussed in the previous paragraph. Notice that we said the information at the start of the string code in the file tells how many bytes to read, but not how many characters are in the string. These two figures are not the same. Now, I said strings can vary in length and complexity. With the UTF way of encoding, different characters are encoded in a different number of bytes. However, all the ASCII characters are stored in just one byte, and you are undoubtedly using only ASCII characters. So this difference is more theoretical than real to you now. Alright, and that's going to wrap it up for today, folks. Kind of a bit of a longer one here, but a lot of good stuff here as we dive into binary files. So we will see you next time.